we're here on stage with Visual Studio and C#10. And we're going to go into all the details that we didn't get to in the keynote. There's me, there's Dustin. We're both on the C# language design team.
Yeah.
And we want to jump right into Visual Studio and talk about essentially just start where we left off last year.
That's what we do.
With records.
Yeah, we've had an ongoing sort of demo now for a while. We think it's cute and funny, and so we keep doing it. But we've been building on it ever since. And actually, it's this demo that's been driving C# design for the last several years.
Totally,
right?
we're demo driven.
Yeah. So this application, it comes from C#9. It uses and it was about showing records and with expressions and sort of the things we get with records. So there's a person record here. We've got with expressions on that, and it shows equality and all of that. And so that's what this demo showed. Right?
That's what it showed. And just to recap, the with expressions, what they do is create a new person object, a new instance of the record that's like the old one, copied from the old one, but with that little thing changed that's mentioned there.
Right. And the first big feature that we added, and it was rough to add. I mean, there's a lot of design discussion that went into it, but we allow you now, because records,
They're always classes.
They're always classes, so we went ahead and let you add this word here.
And say that it's a class.
Right. So it's just really clear and crisp in your code. It takes up 6 more letters horizontally, and that's
how we earn our pay, guys.
That's how we earn our pay.
But so since we were fiddling here, we decided, okay, why? And this is a real feature.
Right. Yes.
We want to allow you to have record structs. So a lot of people asked, yes, structs are already value-based. They already have value-based equality and so on. But there's still some features of records that structs don't have.
Right.
And so we're like, let's take those back to structs and allow you to declare a record struct.
Right. And so we can just declare this record as a struct. This also allows it to take a primary constructor. So I could write a primary constructor up here instead of using properties down below. But this is a record struct. And so what's cool about this is that everything up top works exactly as it did before. This demo outputs the same information to the console, and so it's the difference being kind of where that record gets allocated.
Yeah.
Right.
Yeah. So it's just a difference between class and struct.
Right.
However, as I was kind of getting at before, structs do have some record-like behaviors already. Yeah. In fact, records were inspired by structs to some degree.
Right. And so with structs and doing record structs, we also took a look at some of these other value-based kind of objects and classes and types that we have in the language. And so if you remove record here and just say, let's go back to like plain vanilla struct. Okay, and so now person is a struct.
Yeah, let's see what breaks if we do that.
The only thing that breaks is right here, and that's because structs don't implement equality operators.
They don't have equality operators.
Right.
But so the surprising thing is the with expressions up there, they actually work because we made with expressions work for all structs. Structs already know how to copy themselves. Whenever you assign a struct, you're actually doing a copy. And so the whole copy and modify was actually trivial to implement.
Right, and this goes to we did with expressions, and we've been wanting to do them for a very long time, but it was hard to kind of figure out the machinery of how that would work, and so we did it for records in C#9. But we don't like having features where you get to express yourself in a certain way, but only if you use this corner of the language.
Yeah.
Right, and so now this is about, well, let's let with expressions be used in other places,
wherever it
more
makes
ubiquitously
sense.
if we can do it.
And there's one more corner of the language that's actually value-based, and that we decided let's also make with expressions work for that. And that's anonymous types, which have been in C# since C#3, since we did link and all that. Yeah. So if you actually
I can delete this guy right here, and now it's magically this is an anonymous type. If I hover over, you see that this is now an anonymous type. It's not named person anymore.
And again, the with expressions also work here.
Yeah, everything here works.
Create a new object of that anonymous type and just modify the things you want different.
Yeah, that's fantastic.
So that's very cool. That's the with expressions. But now that we were doing things with structs, we were like, let's go through and modernize structs more pervasively.
Yeah, you know, and this also comes to some philosophical like kind of ideas we have about structs, and especially as we had, you know, designing structs from the very beginning of C#. Structs have always had a lot of protections built in, right? They've had protections built in, especially with the fact that with a struct, it's always been the case that if I have a person, like in this case, a person that is, you know, assigned with the default value of that struct type, or if it is calling the new, the public parameterless constructor that doesn't exist on that struct type that we kind of generate, you know, this kind of synthetic, that this is the same, these actually are the same value,
yeah.
right? The fields are set to the same thing and all of that. And so we try to protect against changing this behavior. Mm-hmm. But I think we might have rethought some of that.
Yeah, we feel like this is limiting structs in various ways. So we decided now it's time to give you the ability to declare your own parameterless constructor on a struct. It has to be public, so it's like completely shadowing the default built-in one, if you will.
Right.
And so that's what Dustin is doing right here. Actually introducing a parameterless constructor that does some initialization.
Right, it needs to do that initialization. That error is not because I've added a parameterless constructor, it's because I haven't initialized all the fields.
Yeah, because structs need to be definitely initialized in all their constructors.
Right, and so in C#10, you know, a struct that is, you know, initialized with default versus a struct that is initialized with a public parameterless constructor might be different.
Yes.
Right, and in this case they are different.
When
right?
you call the constructor and there is one, you actually get the constructor.
Right, because default is just it's kind of like a sugar for saying, just fill it in with zeros.
Yeah.
Right, you know, whatever's there, fill it in with zeros. If it's a reference type, that means it's null. If it's, you know, an integer, that means it's 0, and it's just zero out the memory. But now this will call that public constructor that we've defined.
And so that allows us to go and attack another thing that's been sort of a limitation in structs for a while, which is you can't have initializers in structs.
Right.
In structs, you can't have field initializers or property initializers like you can in classes.
Right, for the same reason, right? Because we don't really have a place to hang that initialization on. We would need public parameterless constructors to do it.
People would call new, and the initializers wouldn't run, and that would be bad, right? But now there actually is a constructor that can run and do the initializers. So now this is allowed. And indeed, if you have initializers, you can leave out that public parameterless constructor declaration that you have here that's now empty. So you can delete it.
Yeah, you can think of it just like a class, right? If you have initializers and there's no constructors at all, we'll generate a public parameterless constructor on a class. We've done that since C# 1.0, and that's now how it works if you have initializers with a struct. Yeah. Yeah, that's cool.
All right.
Now, we've been working on this demo for many talks, and I kind of want to clean this kind of thing up. You know, we've been in a single file, and I would like to now take this and, you know, consider like we're going to have a larger project. And so I'm going to move this into a separate file. I'm going to use a couple of the IDE features to do that. So first I'm just going to move this person type to a new file, and then we can, because we don't want this to be a toy anymore, right?
Right. Let's
not
go
a demo
real.
toy anymore.
This is
so
a
we're gonna
real application.
Move it to a namespace.
Yes. We're growing up today.
Call it like model, because that sounds architect-y.
Yes.
To do so.
Yep. Nobody questions you when you have a model.
That's right. That's right.
So we just used yummy refactorings from Visual Studio to get here. And one of the nice things it figured out was, well, actually, where do you want to
No, it does. I mean, it puts us in the model.
Yep.
And what it does, though, it puts the braces in and all that. And it comes to this point where my soul hurts a little bit, because there's this travesty, right? And the travesty is that in C# since 1.0, 99.99, however many nines you want, classes and structs have been indented by 4 spaces, right? And we have like completely wasted white space. This must have been awful in the early days with like 640 by 480, right? It was just, and we've just been wasting white space.
It just goes off your right edge. Yeah.
Ridiculously so. All your files are bigger. We're deeply ashamed.
It's not that bad, but if we could, that's all because of that namespace and the curly braces and the indentation. So we said, hey, if all files in practice in the world only have one single namespace and everything in the file is inside of that, let's just have a neater syntax. We can put semicolon on the namespace and not have the braces, and everything indents to the left. It's really like, it's a tiny bit of syntactic sugar, but it's going to save you so much indentation, and it just looks so much nice. I mean, this is just yummy.
It feels
Yeah.
good. It
Yeah,
feels
it's good.
succinct and good, and we're just kind of keeping with that theme we've had of removing clutter in C#. Just kind of removing the ceremony, removing all the extra little boilerplate you have
Even
to add.
invisible clutter we got rid of here.
Even invisible.
Even no ink clutter.
Yes.
So that's great. So we've shrunk your code horizontally.
Yeah.
But we also want to shrink it vertically.
Yeah, that's the other thing, right? Every single file that uses, that wants to use a type from system.io has to have that using directive at the top, right? And it's kind of this curse of pulling and using something. It's like, oh, I got to go now and make sure it's there.
Yeah.
And the IDE will add it for me if I use some of the refactorings. That's cool, but then it'll also trick me into removing the usings, and then I need it again later. And it's
Yeah.
like, it's a whole dance.
C#
right?
was designed for very fine-grained, deliberate management of those usings. And it turns out, I mean, it does help with conflicts theoretically and so on, but it turns out it's not actually that useful. And most of the time, if it wasn't for all the space they took up, you would just have all the usings that make sense in this type of project.
Yeah.
And so let's help you with that.
Yeah.
So if I could take all my usings and smoosh into just one source file, that would be a great start.
I have such a source file, and it has all the usings that I'm using so far in this project. And if I go ahead and bring this down and add a new keyword, well, it's not a new keyword. It's a repurposed keyword.
New use of keywords.
Global.
We like to use a keywords in C#.
And global using directives have the scope of the entire project, really, of that compilation. Right?
All the files in that compilation.
Yep.
So now if you go to look at like the other source files we have.
Yeah. Well, first, I'm going to add one more in here because I did that model thing.
Oh, yeah.
And I want to use that all over my project, so I might as well put it here as well.
Yep, great.
Okay. And then I can go elsewhere, and you can see that now everything is grayed out. But here's the great thing, is that the IDE is never going to recommend that I put them back because they're here.
They're here. They're in
Right?
scope.
They're in
Yes.
scope already. That's beautiful.
That is great. So that is sort of a language level cleanup that you can do. Just put all your usings in one file, manage them in one place.
Yeah.
But doing that, we also realized, well, in the old days, every template and so on would put a bunch of usings in there because you probably need them for this type of project.
Right.
And now I guess we could do that in one place, but we said, let's go one step further. Now that global usings is in the language and all these project types have this list of things that you probably want everywhere, we went and just made that automatic.
Right.
So we call this implicit usings, and it's a tooling feature that generates global usings and sort of just includes them in the build. You don't even have them in source code, they just happen.
Right. And they're part of the new templates of .NET 6. So when you go create a new project, they're implicit usings by default.
Yeah.
However, if you want to add implicit usings, if you want to start using implicit usings in your own project, you can go and enable the feature. I brought up the property page here, and I can just search for this in the new property pages, and I can use global implicit usings. And in the project file, it just adds this guy right here, which will be in new project files that you create. And now I can go back to this file. I don't need any of this. That was already added that's already part of this template. That's already part of the .NET 6 build.
Yeah,
So
that's in console apps. So those are the things that all console apps should have available to them.
Yeah.
It means that it's really great if it's both great for us all because we have to maintain less stuff ourselves, but it also means someone walking up to C# and is trying to figure out, well, reaching for the things they need. They don't need to know to go and find a certain namespace. It's all already in scope and ready for IntelliSense to pick up.
Yeah, and there's also the idea that once it's in the project file and the tooling is there, then you can, if it's lifted to that, then you can lift it higher and you have a little bit more flexibility. You can say push this into a directory build prompts at some higher level of your application, use it throughout all your projects. You have the ability to do that now that and honestly you can make usings except when you really need them or where they're special to your application, a thing of the past, and you never have to add using system link again.
So it plays into that minimal ethos that we've also talked about, and you will talk about in the keynote. You'll see later today in the ASP.NET minimal APIs demo and so on.
Yeah.
And we've done several things in the language to play into that. And maybe we're ready to move to the next one of
Yeah,
those.
because these are cool features. I love these, but let's get to, like, these are my favorite features.
Uh-huh.
Yeah, so I'm going to talk about a little bit about Lambda expressions, because those minimal APIs were kind of the impetus for us to go and do a bunch of work here. Work we'd kind of been worried about or put off. You know, there's a design space that was really challenging ever since C#3. When we introduced Lambda expressions. And before I was at Microsoft, I used C#3, and all I ever really wanted to do, Mads, and I think I even might have filed, you know, an external bug on this, but I really wanted to do this, and I just wanted to pick the right thing for me.
I remember that, not because I actually remember it, because you told me about it so many times. I think some young PM at Microsoft gave you a bit of a flippant answer to that one.
I believe that's the case.
I apologize now publicly. But hey, no squiggles.
No squiggles. And so what has happened here is that this Lambda expression provides enough information about the types that are involved, about the argument types, and also about the return type, that it can infer a func or action delegate for us.
Yeah.
And basically, it's embracing the fact that func and action, which were introduced with .NET 3.5 back in the day and C#3, and we added more of them in C#4. You know, but it does say that these are officially what the compiler will infer for these guys.
Yeah, why don't
so
you go hover on? Yeah,
if I hover,
exactly.
you get exactly the same func as we had defined there.
And it's even beautifuler if you do it over parse, because then it's going to do the substitution. You can see. So it knows this is a func of a string command.
Yeah. Now, as I said, if you don't have enough type information, it can't do its job. So if I do this, it has no idea what that argument type is, and it's going to error and say, sorry, you know, this delegate type could not be inferred.
We're smart, but not that smart.
We're not that smart.
Yeah.
I'm sorry.
That's
what we are extra smart. This is something I didn't even realize we did until you showed me this morning. But if we can't infer it to a delegate type, but we have enough information.
Yeah, if we can infer to one of the existing functions, like we'll pick a func or an action type from the library if it's there. But if it isn't there, if there isn't a suitable one there, we won't just go and fall over and say, eh.
Yeah. So for example, if I put a ref in front of that string s there.
We don't have any func types for ref parameters.
So what it does,
it generates one.
Creates a new anonymous delegate.
Right into our assembly here.
Yeah. And what's useful about this, and again, it's in those kind of web API scenarios where I'm passing things in. And today, what we're seeing here is that we're taking that type inferred Lambda type, delegate type, and we're assigning it into var, right? We're assigning it into parse, and we're letting that type flow like that. But I can also put any type that's convertible to here, right, as well. So I could put object here, and that's fine, right? Or I could put delegate here, and this is the sort of thing that those minimal APIs take advantage of, where you can pass in these delegates and it can convert it to the base delegate type.
Exactly. That if you go and look at map-get or map-post, they just have a parameter type that's delegate, and then we figure out the details of which delegate type to actually new up and send you. But that's all. They don't need a ton of overloads for different shapes of lambdas. They can just take delegate, and then it's up. Of course, they get lambdas of all different kinds of sizes and shapes. And it's up to them to then pick that apart and do something with using reflection or however they want to do it. But that's sort of like, that's just an implementation detail on their side. But what the user is faced with is, just give us the Lambda and we'll figure it out. So it's very cool.
It's super cool. And of course, Lambdas have other scenarios that they cover. There's this thing called expression trees.
Yes.
Right? That's also a thing. And something we had to consider as we did this is part of what makes it such a big feature is imagining all the places where lambdas get used, and there's a lot of them.
And Entity Framework is all about queries expressed in terms of expression trees.
Yeah, and you were telling me this morning, this is actually kind of an interesting dance because the compiler does the inference and it comes back to the type that is going to be, the target type that's going to be assigned into, sees that it's an expression, then it has to go back to the compiler and say, no, sorry, this is going to be an expression tree. Infer it like that, right, as an expression tree.
Yeah, in all the previous examples, we were always inferring delegates.
Yeah.
But because the target type is something from the expression tree hierarchy, it'll say, oh, I should build an expression tree instead. The compiler is smart enough to recognize that, go back and say, hey, actually infer a delegate type instead and instantiate that. So this works with expression trees, weakly typed expression types. We'll drive it into expression mode and still pick up those lambda signatures in the right fashion.
Yeah, I think the net result of this is I'm going to see a lot more lambdas with a lot more argument types.
Yes, yes, because people will be putting those in so they don't have to say the delegate type.
You just got to decide where you want your type inference, and I do not want to write that big funk anymore.
Right.
Yeah.
But even that runs out of steam sometimes, though, right?
That's true.
Because we are relying on the fact that we can infer the result type from the shape of the lambda.
Right. And so this one takes a bool, and so we've got the argument type in there. However, if I do what we've been doing and change this to var, it can't infer the delegate type, and that's because the return type can't be inferred from this, because this is a conditional expression that returns either an int or string.
Yeah.
Those don't go together. The lowest thing would be object, but we don't have rules in the language to choose that.
Right.
Right.
And that wouldn't even be the best common denominator, because they both are comparable.
Yeah.
And like what type would we infer here? That's not something we should get into the business of kind of guessing for you.
Yeah.
That now becomes guesswork, and we don't want to do that. So what do we do then? Because when we can't infer the return type, it would be really nice if we could state it somewhere.
And so we can in C# 10, and I'm not sure I'm totally convinced I can look at this right yet and see it, but that is the return type now specified for this lambda expression, so I can use syntax to do that. Yeah. And draws it much closer to all the features we have in local functions.
Yes.
Right?
If you look at it, all the elements of the lambda are in the same place that they would be in a local function, except there isn't a name there because they're anonymous.
Yeah, I mean, you can even, because they're anonymous, right? Yeah. But we can even add, you can add attributes and all of that. We did a bunch of syntactic work to make sure that lambdas had more of these facilities. And so really, I mean, we did a lot in these lambdas. It's actually, lambdas are cooler now.
They are.
Yeah.
So now we have those conversions.
Yep.
People are like, well, but I write my event handlers, for instance. I don't write them as lambdas. I write them as methods, like the old-fashioned style.
In the old-fashioned style. So it's funny when this has been in the language. Method groups have been in the language since C# 1.0, but they rarely get used like this, I think, or people rarely realize they're using them in this way. But that you can assign a method group into a delegate type, right? And you can get into a delegate.
People do it for events, but not many other places.
Right, not in many other places. We went ahead and added that same type inference for this, and so for method groups. So now I could say var here, and that works and is assigned and gets a delegate that points at console.read. And part of the reason that works, actually the main reason that works, other than us writing a lot of code in the compiler, but also is that console.read has one overload. And so it is unambiguous as to what that delegate type should be.
Yes.
Right? All the information is there. So while I've got right here, maybe we've gone a little overboard on console.write. There's 16 overloads. Actually, I think it says, so that's a lot. So if I try and do that, we're not going to make any choices for you. This simply can't be inferred because there are overloads.
Again, we shouldn't try to guess which of the 16 overloads you want a delegate for. So in that case, you still have to do a little bit of work.
Yeah.
But we've taken it as far as we think is reasonable, as far as there's a clear best choice the compiler can take from the information you provided in the source code.
Yeah. So that's most of what we have, right?
Well, there's still things to talk about. We have we've done a few things with interpolated strings.
That's right, with interpolated strings. And so interpolated strings are one of my favorite features that we added in C# 6 because they just make code more readable. Not having to expand out that string.format call with all the curly braces and figure everything out, make sure I was counting correctly. It just makes code so much more readable. But there's a dirty secret.
It's a guilty pleasure.
It's a guilty pleasure because interpolated strings, there's a lot of hidden allocations involved, right? Because there is that string format call.
They call string.format. It has to allocate a string builder. It has to allocate all of the intermediate strings. And there's a bunch of work involved. And in some cases, that really hurts. Like you're appending to one string builder, like here, and you just want to put that interpolated string there. But if that means firing up another string builder and painstakingly constructing a whole string just so you can append it to another string builder, that's not the optimal code.
I am super dirty. I do this anyway. And a lot of people are like me in that sense. They're like, it just reads better. I'm just going to do it. It can't be that much slower, right?
Right.
And so in .NET 6 with C# 10, we've gone ahead and we've done some work here. We've done some work to make sure the patterns you were writing are simply faster, right? So like with string interpolation, we've created a library pattern.
Yep. Essentially, a method like append can go and say, you know what? If you pass me an interpolated string, don't do the usual thing, compiler. Instead, I have this special handler here, a string interpolation handler, and just let me work over all the bits.
Right.
And the compiler and the handler do a little dance that avoids allocation, and that can even avoid executing some of the code in the interpolation holes if it's expensive. We don't get time to show all that. But, and can even change the semantics of how the string interpolation happens if it wants to. So it's really like building one of these handlers is advanced. But we've built a bunch of them for you and put in, if you remove the hover there and just quickly expand some of these, we've done it for append, string builder append, so it does the right thing and append 3 times instead.
Debug assert, which is great because, when you use debug assert with an interpolated string, it creates the interpolated string every time, no matter what the condition is.
Yeah,
right?
And then the assert is going to do nothing because the condition is true.
Yeah, hopefully your program's correct and it's true.
And if you ever get to where the condition is false, we're going to crash the program right after. So we want to only ever build that string in that case. And the interpolated string handler for debug.assert indeed does that now. So even that expensive calculation in the hole there only happens. It only even gets called if the condition is true.
And there's one last API we want to mention, and that's we've added a string.create method that takes a culture, because when you do a string format call, by default, that's current culture, right? And so if you're trying to do something that's kind of machine neutral as opposed to something that's meant to be human readable by a locale, then you want to make that invariant culture, right? But there's no real way to plug that into an interpolated string.
Except there is now.
But now there is, and so that's exactly what this does. Takes the interpolated string, takes the culture, does the string.format call for you, building up
with that culture.
With that culture. So that's fantastic.
That's all we wanted to show. There's more in a recent blog post, and again, watch the minimal APIs talk later today and see some of this in action. Yeah, thank you very much.
All right.
Well, that was amazing, Dustin and Mads. Thank you so much.
Someone actually said on Twitter, who would guess lambdas would be cool?
Right?
That must be someone young.
I don't know. I can't tell. I'm not going to make a judgment call. But yeah, do you have a couple of housekeeping slides you want to do?
Yeah, we don't have too many questions for either of you, but thank you so much. We do have a few slides for the event. Are you ready to learn and have fun, Scott?
I am. We've got a ton of stuff. We're going to be here for, another 7 or 8 hours. Plus, we've got all night long. And tomorrow, there's a lot of great stuff happening this whole week.
Yeah, several full days of content. This is just a conference at a glance. Don't forget to attend. We'll be here until 5 p.m. Pacific, but those are virtual attendee party from 5 to 6 p.m. Pacific. Don't want to miss that. Thank you to all of our amazing speakers. We have tons and tons of speakers for you, and it's going to be a really, really great event. Thank you, everyone. And
all of this is going to be available on demand, right? So if you're in a different time zone or you're missing anything, these are all going to be available for you. So you can be sure to check those out. And you can always ask questions at #.netconf, and we'll possibly put your question up on the big board.
And ask the big questions.
Yeah.
We have tons of conference swag for you, .NET Conf swag, and we're actually giving everybody who uses this discount code $25 off anything in the store plus free shipping, and that is international. So it's .NET Conf 2021. Go and get your swag. It's amazing. We just updated the store with tons of stuff.
Talk to me about this notebook. This notebook is pretty cool.
Oh, yes. So the notebook actually is a seed notebook. So you can plant the first page, and it actually has seeds in it, and they will grow wildflowers. So that's pretty exciting if you wanted to compost your notes and paper.
Very cool. Most of my notes are trash, so that makes sense.
We have virtual attendee parties. We have trivia questions. We have challenges to get prizes. The swag bag I just mentioned. We have tons of digital swag that you can get on the website as well. And over $125,000 in prizes for completing these challenges at this event. So go and check out that page. You don't want to miss out on that.
Yep. So like we mentioned, those attendee parties, there's an Xbox One X, there's $500 gift cards, lots of software. There's going to be one at 5 p.m. Pacific on the 9th and one at 7 a.m. on the 10th. So there's 2 options for different time zones. And just as we get ready to go into our next talk here with Daniel Roth, reminder, As Jamie pointed out, that there's a great challenge you can check out at dotnetconf.net/challenges. Check out the secret decoder and possibly win that Xbox One, a drone, gift cards. Very cool stuff.